Carps is a benchmarking framework we recently developed to compare n hyperparameter optimizers on m benchmarks. Before we dive into Carps, I want to have a very quick comment about another tool which is very much in its alpha phase. It's called the Hypersweeper, and I just typed the slide, so it's a bit cryptic. Hypersweeper can use different optimizers, and there we can have nicely evaluate objective functions where the objective functions itself are parallel. So we can parallelize parallel objective functions, which is really nice. We used it for our last benchmark, RBench, for reinforcement learning. And there we did hyperparameter optimization for reinforcement learning. And of course, in RL, we can also parallelize. So we use that framework, and this is something we develop right now. So just as a quick advertisement, if anyone has this problem and wants to do that, we also have DEB and other optimizers for that. Okay, but actually I wanted to show you Carps, or actually rather a tutorial or small hands-on session. And so whenever we develop the hyperparameter optimization methods, we need to benchmark it. We need to know how good is our new optimizer. And for this, we need to select appropriate benchmarking tasks among many, and also appropriate baselines. And of course, you need to integrate those benchmarks and baselines. And what I did before is I had the same experimental setup, but each time kind of new and kind of new again. So this is why we have Carps now. Carps is a comprehensive experimentation pipeline. We can define and run experiments, also large-scale experiments, so 20 optimizers on 20 tasks, or 200 or 2,000 or whatever, on 20 seats very easily. We have logging, and we have also analysis methods and create nice plots. And Carps is basically a lightweight interface gluing together the optimizer and the benchmark. That makes it really easy to add a new optimizer yourself, which is the task for the next very few minutes. So at least we will try to do it. And also benchmarking, adding new benchmarks is easy. And we already integrated 5,365 HPO tasks. You can choose from 6 benchmarks, and we also have many optimizer variants. We also propose subsets to have some pre-selection to test, to develop stuff on. And we also have experimental results for some. So let's have a quick look at the interface. So it's pretty easy actually. So the optimizer class runs the optimization. And then if you add a new optimizer, that would be a subclass of the optimizer, and the new optimizer basically needs to implement ask and tell. That's it. And then the optimizer interacts with the problem by asking the problem to evaluate itself. And this is basically how the setup is. It's lightweight, and it's not much more code than that. As I said, we have many optimizers, and right now I think we have 2 or 3 more from different optimizer families. So we have Hebo, DEB, Scikit Optimizer, Tuners, Merck, Navigrad, and SignTune for different scenarios, black box, multi-objective, multi-fidelity, and month. And month is multi-objective, multi-fidelity. We also have, as I said, many benchmarks. So HPOB, HPO bench, YAPO, Bebop, PyMo, and MFP bench. So basically everything, or almost everything there is right now. And what is also nice, we mostly have tabular and surrogate benchmarks. That means also evaluating the black box functions is quite cheap. And the real function evaluations that most of the time comes from Bebop. Bebop are synthetic functions, so also cheap. And we also have a diverse distribution of hyperparameter types, just so that you know. And as I said, we have some plotting capabilities. We can have a critical difference rank plot based on statistical tests. Thanks to Lennart for his implementation. He's just not here right now, but yeah. And we have performance over time, and we can also inspect the performance for each optimizer on each problem. So you can have beautiful heat maps, and also look at box plots of the final performance and Spearman rank correlation. So that's in there already. Yeah, that's it. Actually, that's the overview of carps. And now we would go to a very short, like 15 minutes of tutorial, where the task is to implement your own optimizer or maybe implement random search. You can just go to the tutorial, and also don't worry if you don't want to implement an optimizer, but just run the notebook. There's also a master solution, and it also should run. I think I imported another optimizer in place of the class you are supposed to implement, but it basically shows you how to use carps, how to add an optimizer, and points you to more tutorials how to use carps in general. Do you have any questions so far? Otherwise, let's spend 15 minutes on the hands-on session and then a quick wrap-up. Imagine if you now have implemented your optimizer in carps. Actually, you don't need to work directly in carps. You can also develop optimizers or benchmarks in your own package, but run together with carps. For this, we also have examples. So that's step 2, and the next steps could be now. And what is also interesting, especially if you yet don't develop any optimizers or any benchmarks, but if you want to run a large grid of configurations, for example, train a neural network and many seeds and many tasks, you can do that very, very easily with Hydra. And for this, we also have a small tutorial. So a basic command now in the carps context looks like this. We run carps for the optimizer random search for all of the bebop problems that match our glob patterns. So we don't even need to specify our 365 problems or how many we have. And then we can also say, hey, I want 10 seeds. So I can just specify seed range 1 to 11. And then -m. The -m stands for multi-run. And then Hydra automatically creates all those configurations and runs them. And the nice thing, that happens also on the cluster, so it can automatically schedule and launch jobs, for example, on Slurm or Ray or via JobLib. So that's very convenient, and I've used it now since 2-3 years in my own research, so Hydra. So depending on what you do, most likely this will be useful for you. Also, configuration files instead of argparse, everything is clean and nice. Also, when you run that, the config is automatically logged, so you can rerun stuff. So I'm a big fan of Hydra. So yeah, and carps uses Hydra for that reason. So we also have a tutorial on that. You can also just go through it or check the Hydra docs. So it's very worth to take a look at Hydra. And of course, look at carps, but if you don't develop or if you are not in that use case, I can understand it, but look at Hydra. Yeah, and then if you want to contribute to carps, we also have contribution guides for that. Contributions are always welcome. So if you have your own optimizer or benchmark, just let us know. Also, the Hypersweeper I just talked about also has an interface to carps. So the Hypersweeper, which also is based on Hydra, can use all the carps optimizers, which makes it really nice, actually. Yeah, and then I have one final slide, but I think I almost talked about everything. So I use carps now for my own research, and also students of mine use carps. And for me, if I have a new idea for an optimizer, I need to implement one script, one configuration file, if it's a small idea, and then I can run experiments and plot, and I don't need to worry about this whole experimentation pipeline. So it's very useful for us or for me and students. Yeah, carps. We can benchmark and optimization methods on them benchmarks. We have a lightweight interface. We have many tasks. And you can easily add your own. And we have tutorials. And you can try it in a different way than the tutorial. So thank you for attending the tutorial. And now I would like to hand over to Marcel.